You guys are a bunch of boogers. Let's say shut up. So if we're going to graph an exponential function, we'll start by making an xy table. How do we choose the x's for this xy table? Everybody agree with that? So what is our h? What is our h value? -1. So the x's I'll pick are -3, -2, -1, 0, and 1. Everybody happy there? How do I find those y values? I'm going to use my calculator to get them all at once, but you could plug them in one at a time if you wanted to also. That's not incorrect. Let's see, I wrote something different than last hour. This is what I typed in. So I type that in, and then I'll go to my table set. My table minimum value should be -3, and my table's going up by 1s. So that's all set. And then we'll hit graph. So my y values are -14, -8, -5, -3.5, and -2.75. Yeah, that gave me the table. And again, notice above the graph button in blue is the word table. So to get the blue command, you press the second button and then the button with the blue command above it, and it'll give you the blue commands. So it is like right there on the screen. Okay. There's one other piece of information that I need to get from the equation before I start drawing the graph. That is the good. And how do I find the horizontal asymptote? Y equals k. So in this case it is -2. All right. So let's draw this guy. So 2, 4, 6, 8, 10, 12, -14, 1, 2, 3, 1. I'll start first by drawing in my asymptote here. And then let's plot some points. And then we'll attach these. I missed a little bit. I'll just make those points bigger. And no one will be able to tell the difference. Everybody happy with how I drew that? Okay. Let's do the domain and range now for this. The domain should be easy. What's the domain for all exponential functions? All real numbers. Nobody get that wrong, please. The range now, if I could do this two ways. One, since I have the picture, I could look at the picture and notice that all my points are below what y value? -2, the horizontal asymptote, right? That's a little risky, though, because if I make a mistake on my picture, I might get the range wrong also. How can I tell that from looking at the equation? Well, if the a value is 0, or less than 0, the range is y less than k. If the a value is positive, greater than 0, then the y value is greater than k. Everybody's okay with that idea? So you can use that rule to get it straight from the equation, or you could look at the picture and see which side of the asymptote all of your points are on. My suggestion to you is you use whichever thing is given to you in the problem. So if you're given the equation, I would find it via equation. And if you're given a graph, I would find the domain and range via the graph, because I don't want to make a mistake somewhere and get something else wrong because I screwed something else up before it, right? Okay. Let's do a getting the equation from the graph problem. How about that? Oh, good. I'm glad you guys agree.
Yeah.
So the equation that I need to write is in this form: a times b to the x minus h plus k. One of the values here that I need, I get almost for free. What value is that? K. What is k? -1. It comes just from the horizontal asymptote. You can get that immediately just by looking at the picture. Okay. Now what I'm going to do is I'm going to pick one of these values to be my h point. Which point would I want to pick to be the h point? 2, -1/2. And I typically want to pick the one on the curvier part of the graph. Yeah, but it gets a little bit grosser if you don't pick. Trust me, like the other, like finding the b value and stuff gets the algebra gets a little bit grosser. Okay. So that's going to tell me this is the point h comma a plus k. So immediately now I have an h, and I know that -1/2 is equal to a plus -1, which is my k, right? So that allows me to solve for a readily. So now I have my a, h, and k. Everybody happy with that? For k. Yep. So the last thing I'm left to solve for is b. I'm going to use the other point now, and I'm going to use that as an x and y, and I'm going to use that to solve for b. So if I plug in y equals 4, a is 1/2, b is what we're solving for, x is 1, h is 2, and k is -1, I have this equation. Everybody agree with that? I'm now just going to solve for b. What would I want to do first to solve for b? Add 1 to both sides. And I notice that 1 minus 2 is -1. What would I do next? Divide by 1/2, or rather, multiply by 2. And I guess at the same time, I'm going to observe that net b to the -1 is 1 over b. And now to solve this equation, I'm just going to cross multiply. So I have 10b equals 1, or b equals 1/10. So I have everything I need now. So 1/2 times 1 over 10 to the x minus 2 minus 1. So none of the arithmetic in there is terribly complicated, right? You just have to remember what points I'm using to do what with, right? So that's the part that you just have to kind of remember what you're using these things for. Okay. For the story problems, you're going to be using these 4 models. So the 4 models we've seen are the growth model, the decay model, the discrete compound interest model, and then the continuous compound interest model. So you'd certainly, in addition to remembering what these models were, you'd also want to remember what the letters represent. So in each of them, what does V of t represent? The value at time t. So V for value. The A's are the initial amount, and the P's would be like the initial investment. Really, they mean the same thing, the initial value of whatever it is you're looking for. In the growth or decay, the R is the rate of growth or decay written as a decimal. More often than not, those things would be given to you as a percentage. Make sure you convert your percentages to decimals. And then in the growth or decays, the value for t is some measurement of time. How do you know what unit of time that t is in? It's going to match your rate of growth or decay. So if it says in the problem that something is growing by 8% per minute, then the t is in minutes. If it says it's growing by 7% per 1,000 years, the t is in 1,000 years. So it's like a millennia or whatever. So it's going to, whatever unit they say the growth rate is the unit of time t is in. Okay with that idea? If I look at the discrete and continuous formulas, the value for R is the interest rate written as a percentage. So again, make sure that for those R's, you're converting those interest rates into a percentage. In the discrete formula, N is the number of compounds per year. That will be given to you in the problem in words. So if it says the interest is compounded annually, N is 1. Okay, because annually means happens once per year. If it was semi-annually, it would be 2. If it was quarterly, 4. If it was monthly, 12. If it was weekly, if it was bi-weekly, 26. So bi-weekly is every other week. And that's a popular one because how often do most people get paid? Every other week. So bi-weekly, 26. Half of 52? Oh, yeah, 1 over 6 makes 0 sense. Yeah. And daily is 365.25 if you want to be really precise. 365 is fine. No. And then T will be almost always in years, right? Because if we're talking about compounding, the unit of time you're almost always going to be dealing with is years. Now, how do I tell the difference between the discrete and the continuous formula? What do I need to see, and what phrase do I need to see in the problem to tell I'm dealing with the continuous one? Has to hear compounded continuously to use the continuous one. If it says compounded weekly, I would use discrete. If it says compounded annually. If it says compounded every second, discrete. If it says compounded every nanosecond, discrete. If it says compounded continuously, then use the continuous one. Okay, so that's really the phrase you need to see. The only other way they might say that is like compounded every instant would still be continuous, right? Because how often is an instant? All the time, right? All the time. Everybody happy with this? I mean, maybe I'm going to do both of them. All right, let's do an example here. No. Yeah, I carry around baby pictures of myself in my wallet.
That's so valid. That's so fair. It's a compliment. That's so fair, though.
Okay. So here it says Mr. K buys a comic book in 1980 for 25 cents. He sells the comic in 2018 for $765. What is the growth rate for the comic? First thing we need to do is establish which model we need to use. Which one of the four models would I want to use? The growth model. Everybody clear on that? Okay. Which value inside of the growth model are we going to be solving for? V of t, A, R, or T? R, right? Because what is it asking for? The growth rate. Okay, let's fill in the rest of the values then into my model. What value goes in for V of t? 765. What value is going to go in for A? 0.25. And then R is what we're solving for. And then what value is going in for T? 38. Everybody happy with this? Okay. So how am I going to solve for R? What's the first thing I should do? Good. Divide by 0.25. When I do that, I get 3060. Then what should I do? You could graph it, but we know enough to solve this algebraically even before we started chapter 15. How would I cancel out that 38th power? Yeah, 38th root. So you could still graph it and do it that way, but you don't need to. When I do that, I get about 1.24. So when I subtract 1 from both sides, the R is about 0.24 or 24%. And I would say per year. As long as it's not a variable, yeah. Yep. Correct. if you're solving for an exponent, we're going to use the graphing. But here we're not solving for an exponent, right? So that's okay. We can find that thing without having to graph. Although you still could have. You could type this into one side and this into the other and find the intersection. The only thing you'd have to be careful here is that your x min and x max, what values would you want to pick here? 0 to 1. Why would 0 to 1? R is a percentage written as a decimal. So like it's going to be between 0% and 100% most likely. So the R values are going to be really, really small. So your x min and x max would have to be a really small range. And it's unlikely, it's very likely that that would confuse you trying to do it by graphing, although you still, very possible to do it by graphing. And if you were alert enough to see what's going on, it would be no problem. But if you picked 0 to 50, you'd probably press graph and you wouldn't see anything because it would just be stuck on the x-axis because it would just shoot up super fast. So, just saying. Okay. Let's do another. Yes, we probably have time for one more. Yes, sir. Yes. I don't want it recorded and then posted to the internet.
No one's gonna watch like 30 minutes of this just to hear it. Nobody's even gonna know it's a off. Have fun. Wait, I'll do it when he comes back. Yeah, do it when he comes back.
Okay. So we're asked here which option is the better choice. So you're able to choose one of these two things. You get $5,000 invested at 3.6% interest for, oops, we should say something there about how often it's compounded. Compounded weekly for 6 years. And that, or you can have $4,500 invested at 4.5% interest, compounded continuously for 6.5 years. So if I ask you which one of the better is the better choice, I'm going to ask you to justify your answer using mathematics. So you can't just say option 1, I'm guessing, right? Like you have to give me a mathematical argument for this. What would be the easiest mathematical argument you could make? Just compute the value for each of these, right? And whichever one is the more valuable one is the one you should pick. So both of these are dealing with compound interest, right? So which compound interest formula should I use for option 1? The discrete one. How did you know that? Because it says it's compounded weekly. And then for option 2, which formula? Good, the continuous one. How did you know that? It says compounded continuously. Good. So we're finding the value, the future value. So the P is 5,000. The R is 0.036. The initial amount. Yes. And then the other one, we're solving for V of t. The P is 4,500. E, 0.45 times 6.25. Anybody with a guess about which one of these is going to work out better before we actually do the computing? Okay. Most people... because I made a mistake. Thanks. So most people, it sounds like, are picking the second one. think you might be disappointed. Oops. I just typed in 0.36 instead of 0.36. I'm like, $43,000, that's impossible. So that's that one. And this one. Oh, look at that. You guys were wrong. Option 1 is slightly more valuable. Because you wanted it to be bigger. Ah, because you thought it was just going to differ in the 10 spot instead of the 100 spot. No, not when all the different quantities are different. So so you have like the PNRT. If like even two of those are different, it's really hard to tell which one's going to be better unless one of them is like massively, massively better. But in this case, where like the P was different, the R was different, the N was different, and the T was different, if they're all different like that, unless one of them they're all better, it's really hard to tell, right? So here in the beginning, the P was better for option 1, the R was better in option 2, the T was better in option 2, and the N was better in option 2. But it was still option 1 was the better one because the P was kind of significantly better in option 1. So it's really hard to tell just by looking at those values which one would be better.